Good. So we have to determine the local max, local min, or saddle point of all of this function, right? Are we clear? So what do we do first? We take the partial derivatives. Okay. Are we clear on this? Right. So we will take partial derivatives. So partial derivative is, so first we are doing partial derivative with respect to x. So when we do that, okay, I'm catching your attention here. When we do that, all we have to do is differentiate it with respect to x, treating y as a constant, right? We did that before, didn't we? Right? So we have, so here is the whole thing. So first we are differentiating this. So if y is treated as a constant, what will happen? We get a 2x, right? Don't we? Are we clear? Then we are leaving this as unaffected. Are we good? Okay, just when you tell me, sir. Are we good? Yes. Now, so we are using simply the product rule, right? So then we take this factor and then we're going to differentiate this, right? Okay, so when we are differentiating that with respect to x, y treated as a constant, what we will do, we'll use the chain rule. So the derivative of an exponential is the exponential itself, right? And then the derivative of this power with respect to x is negative 2x. So far so good? Good. So then we will go further, simplify it, right? So what do we get here? We get 16xy, right? And here we are going to get what? Negative 16x and this quantity. Are we good so far?
How did we get y over there? 16y, 16xy?
I have no idea. How did we get that? Because we shouldn't have gotten it, right? Okay, looks good. I'm sorry.
That's fine.
Just so happened. I don't think we should have it here. We should not have had y there. I don't know how it showed up. And here negative 2x. Good. So then we are going to get what?
Partial of y.
df over dy, right? Okay. Good. So this becomes along the same line. See here, it will be 16y. We are going the same way because the only difference we have is the exponent here, right? So now instead of positive, what is negative, what we will have? Positive, and we are going to have a y, right? And all these guys again, right? Okay. Now we get the critical points, right? Those coordinates, x and y value for the critical points. How are they obtained? They are obtained by setting these values equal to how much? 0. Okay. Jocelyn, you are with us, right, sir? So far, so good? Okay. So we have to have this equal to 0 and this equal to 0, right? So this equal to 0 means what? Let's write it down. So we have 16x is a common factor here, isn't it, right? Notice this here and this. And then we got 1 minus, now it's getting, I wouldn't say complicated, it's getting to look nicer, right? So this is what this gives us, right? Are we good? And then here we get same kind of a thing. Here I have a y, right? Positive. And there I go, positive, right? Okay, so let's see. So we have to get the values for which this is 0 and also this is 0, right? Are we good? Okay, so notice this. So one point is obvious, right? that these guys are both 0 when x and y are 0 together, right? Are we good here? Okay, so that's one place. We know this can never be 0, right? So that's out of question. Make sense? Okay, so then this is 0 means, here we have x equals 0 for along this circle, right? This is 0, right? Are we good so far? And here we're just going to choose all possible. We're going to choose all the possibilities, right? And then, and that's it. Because see this here, this quantity can never be 0, right? Because this is never negative, so nothing can kill 1 here, right? Makes sense? And x, so here we have this. So if x is 0 and y is 0, that's when this happens, right? Hansel, you look puzzled.
I'm a little puzzled over there. Why can't we like just do x square plus y square equals -1?
Because x square plus y square equals -1 doesn't have any real solution, does it?
Okay.
Right?
Yeah.
Because the sum of two squares will never be negative. With me?
Yeah.
Okay? Good. So this is one part. That is x and y both are 0, right? And tell me the other part here, that if the other part is that if this is 1 and y is 0, right? Are we clear? If this is 1 and y is 0, then both of these will be 0. With me? Jocelyn? Yeah, because see this here? If this equation is true, then df over dx is 0, right? And if y is 0, then df over dy is 0. Are we together? Are we good on this? Good. Very good. So what does this mean? This simply means that x square equals 1. Oops. And what at the same time? Y is how much? Y is 0, right? So x square is 1 means x is plus or minus 1, right? So the other points are -1, 0 and 1, 0. Very good. So we have 3 critical points now, right? I mean 0, 0, 0 and these guys. So far so good? Yes, sir. Okay, so these are the criticals. Let's call it criticals. I'm not calling it point because we are lazy not getting the z coordinates of these guys, right? Let's just say criticals, right? Okay. Now, next thing, we compute the discriminant, right? Remember, what's that? We take the second derivative. Okay. So look at this here, Jocelyn, because he didn't tell you. That is what we do here is this. We compute. Tell me what that is, Hansel. You are working on it. So this is like you compute d2f. Oops. Over what? I'm forgetting. You tell me because you are doing it more recently than I am.
Dx square.
Dx square, right? Jocelyn, are we good? Yeah. It's not too much. Don't think you'll have to memorize it. No, I guarantee you'll be fine. Okay. See this?
I haven't done this section.
Huh?
I haven't done
No, you are this far. Did you follow me that far?
Yeah.
Okay, then just keep on listening at least. This is called, I think this is called discriminant. Am I right or wrong?
B square minus 4ac.
Exactly, then that kind of a thing. Yes. So don't say I'm not that. You are that far. I mean, see, we are just catching up. All right, and we will fill in the details later. Okay. So are we good? d2f over dx dy. Okay. Are we good? Right. And this square, right? So what we do is that we compute this quantity at these points, right? Don't we? Okay, so we don't know what those values are. Let's get those down here. So here we got these guys, right? Are we clear? So we have these. So we're going to compute these values very quickly. Okay, are we good? Okay, now I'm going to turn the video off because we will come back to it after we have calculated these values. We don't have to show at this stage these steps in the video, right? So what we did was this. So we just went ahead and we computed the second derivative of this quantity with respect to x, right? Then we looked at this and computed the second derivative with respect to y, right? Now I have to get this value. So what I will do is I'll differentiate this partially with respect to x, treating y as a constant. Are we good? Good. Very good. Okay. So who were our criticals? They are right here, right? So let's look at these guys, right? And so we will do this. Well, let's write these guys at our critical values, okay? All right. So where is this second? I'm looking for a symbol. Just give me a moment right here. Okay. Right here and here. Okay, good. So we got this. So remember there was one critical number. What was that? 0, 0, right? Are we good? Okay. So at 0, 0, what happens? We get a 16, right? Are we clear? Then this is out, 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 right? Are we good? Make sense? Okay. And we will just also do this at 1, 0 also. Yes, go ahead.
So what happens to the y? Y is going on
X square is, that will be e to the 0, right? E to the 0 is how much?
1.
1. So that's why we will simply have 16, right? Are we good? Okay. Then here we will have we have 1. So we got 16. Then e to the how much? Negative 1, right? Then we get negative 32. E to the how much? Negative 1, right? Are we good? And then we get negative 32. And again e to the how much? Well, negative 1. Are we good? Okay. E to the negative 1. And then here 1, 1 is 0. So then we get plus 32 e to the negative 1, right? Are we clear? Okay, so what happens? This becomes negative 16 e to the negative 1. If we did not make any mistake, and if we made any mistake, we will all be blamed for it, because here we are simply doing basic differentiation, right? Are we good? Okay, so then let's look at this guy. If I have a negative 1 instead, what will I have? This will, so x is how much here? Negative 1. So that will square, square, square. I think it will stay the same, won't it, right? Do you agree? Because it's all x squares all over, right? So it will be how much? Negative 16 e to the negative 1 still. Okay, are we good? So now let's get these guys at the same places. Okay, so first thing we hit at is what? 0, 0. So at 0, 0 this will be what? 16, right? Then we go at 1 is 0, right? Makes sense. So what happens? 16. This will be out, right? Am I clear? Because y is 0. This will be plus 16 e to the how much? -1, right? Are we clear? This is out, isn't it? And this is out. Oh, that was pretty good, wasn't it, right? And then what we have is we have see this here 1 0, right? Oh, yeah, here we have a good situation. Everybody is out, isn't it? Right? See this here? All these guys are out, right? Why? Because see y is oh no, first let's get it 0 0. 1 second. At 0 0 everything will be 0, right? Yeah, go ahead, Jocelyn, you're saying something.
What gives you 0? This one gives you 0.
Right, yeah, because see
This one cancel, and this one's here.
no, because I'm substituting x equals 0 and y equals 0. Are you with me? Right? Okay. So that's this. And then the other guys will be 0 as well, right? So this would be 0 just because if y is 0, everything has a y there, right? Okay. And this looks that's a 0 too, right? Are we good? So what does so let's compute this quantity at what? At 0 0 first. So what was it here? Let's look. This was positive 16, wasn't it? Df over dx square here, right? And df over dy square was what here? Just a second.
You can find that.
Okay. Oh, no, no. One sec. We didn't find it, right? Okay, yes, we were so lazy, right? See this here? We didn't find that. These, I think we found it somewhere. Oh God, we missed that. It's not you missed that. We missed that because.
No, I said
No, not you. We missed it, right, Jocelyn? I came late and I'm putting blames already, right? That's okay. So yeah. Okay, look, come on. You can go to bathroom. So we will just finish it while you know during the. No. Okay, let's. Okay, so we have this quantity as 16, right? Are we clear? Okay, and then we have. No, sorry. First we noted we had this as 16, and this also happens to be how much? 16, right? So we'll put that as 16, and this is 0. Are we good? Okay. Now we are going to write it for the -1 0, right? Okay. So where is df over dx square at -1 0? Okay. I think 1 0 and -1 0 would be the same thing, right? Am I clear?
Actually, it's different.
Oh, it's different. Where?
Yeah.
Oh yes, that is different. I'm so sorry. I made a mistake. Sorry. So, right. The value is these are the same, but the okay. Good. I got it. So here we go. That's -16. That right. And now we have to write to df over dy square at -1 0. Okay, so where are we? That's I'm erasing it. We did all that arithmetic, right? Are we good? Okay. And this guy is again how much? This guy is 0 anyways, right? Are we clear? Then we go to the third one, which is not going to make any difference. So we can just change all these guys, right? See this here? +1, +1, and +1. This is 0, right? So for here, what happens is this, that at 0 0, right? At 0 0, we have what? We got help at 0, 0. This will be what? 16 times 16. That is 64, right? Isn't it, right? All right. See that? Wouldn't that be 64, right? 16 times 16 minus 0 square is 64, right? Are we clear? And then this guy is greater than 0, right? So what did the manual say there? That we are going to have a local min here, right? Very good. So we will have a local min here.
So one question, I see
So,
that the word deep is more than half an hour first to solve one question. It's a very big thing. This will come in first because it took time.
let's not put that on the video for the world to watch, right? I mean, because we are explaining to each other, right? And I was late, embarrassed, and tired, right? So let's think about that point later, okay? All right. So where are we here? Okay, so here we have a problem. The problem is that if you look at this guy here, see this here? Okay, what was that? Say negative 1, 0. Okay, then this simply is a negative quantity. These two multiply to what? Negative, right? What happens in this case? We have a uh, 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 see,
Oh, sorry.
in order, say that again.
Saddle.
So we have a saddle here, right? Am I clear? And I think we have the same situation here as well, right? Are we clear? So we have a local min, and so here